everyone, welcome to today's video. My name is Ray and today we're going to be going over matter. This is the very first video of the chemistry series. So what is matter? Matter is anything that has mass and occupies space. Everything around you is matter, including yourself. Matter is either a gas, a liquid, or a solid. A gas is the air you breathe, a liquid is the water you drink, and a solid would be the phone you're currently using to watch this video. Matter itself is specifically composed of atoms and molecules, and people think that they can use these two terms interchangeably, but that is wrong. Do not ever do that, because atoms and molecules are not the same. Atoms are submicroscopic particles that are the fundamental building blocks of matter. The keywords here are fundamental building blocks. This means that atoms cannot be broken down into anything else because they are what's used to build everything else. And to put that in simpler terms, it's atoms are, at the bottom of the pyramid. Everything else is made because of atoms. Molecules, however, are made up of atoms, and they're made up of specifically two or more atoms that are joined together in specific geometric arrangements. And the keywords here are specific geometric arrangements, because you can have atoms of oxygen and hydrogen, that if these atoms are not arranged as H2O, your product will not be water, right? So your atoms need to be arranged in a specific way so that you can get the product that you want. And then finally, chemistry is just the study of matter and its properties and transformations. And in the pictures below, we can see an atom, a single particle, and a molecule, which is made up of multiple atoms. First, let's start by talking about stages of matter, specifically solids. Solids are defined by shape and volume because they are made of particles that are held together and that are rigidly in place. So what does this mean? To put it into perspective, if you have a solid cube, right, that cube has the shape of a cube and a specific volume. You take that cube and you put it inside a mug. Will that cube take the shape of the mug? No, it's still going to be a cube and it's still going to have the same volume. So because the particles in solids, as you can see on the image to the left, are so rigidly packed together and so in place, their shape and volume will always be the same, right? And this makes them incompressible because their particles are not moving. There are two types of solids that we need to know. There are crystalline and amorphous. Crystalline solids have their atoms and molecules arranged in geometric patterns that look nice to the eye. You can take a look at the image in the bottom left corner. You can see again that there's a long range repeating order that makes it look nice. Examples of crystalline solids are diamonds and salts. The other type of solid is amorphous solids, and in these types of solids, the atoms and molecules do not have a long range order. They're more disorganized and kind of look like a blob. Examples of these would be plastic, rubber, or glass. Now let's talk about liquids. Liquids are a little bit different because their particles, while they're close together, they have the ability to move around, which makes liquids more fluid, right? But then again, because the particles are still closely packed enough, liquids are, like solids, incompressible. So what's the difference between liquids and solids? Well, since the particles have the ability to move around a little bit, their shape is not going to be definite. Their volume will, but their shape will not. They're not going to have a specific shape. Instead, they're going to take the shape of the container. And the best way to visualize this is to look at these two images at the bottom. These Coca-Cola products have the same volume, right? They have 12 ounces of Coca-Cola in them. What is the difference? Well, that one of the liquids takes up the shape of a can, while the other takes up the shape of a bottle. It's the same amount of volume, it's the same amount of liquid, but they do not look the same. One looks like a bottle, one looks like a can. So the key takeaway is that, yes, liquids are defined by their volume, but they're not defined by their shape. They're going to instead take the shape of the container that you put them in. Now let's talk about gases. Gases are completely different from solids and liquids. They actually have indefinite volume and indefinite shape because their particles are so spaced from each other that they're freely movable. And this makes gases, unlike the other two, compressible because the particles move really, really fast due to the vast separation that they have between each other. So this means that a gas can take the shape and the volume of their container. These two aspects of gases are indefinite. Matter specifically is made up of pure substances and mixtures. We've talked about pure substances before. It's elements, compounds. It's these things that you can't break up because they are in their purest form. But we have not talked about mixtures. There are two types of mixtures. There's homogeneous mixtures or homogeneous, and there's heterogeneous mixtures. In the next slide, we're going to talk more about it. So elements and compounds, again, they're considered pure substances because they cannot be broken down, right? They have a constant composition. But mixtures can be broken down because they can either be homogeneous or heterogeneous. Homogeneous mixtures are these that cannot be separated, right? The example I like to use is a drink of Kool-Aid, right? You first have your Kool-Aid powder and a glass of water. If you put your Kool-Aid powder in the water, mix it, there's no way for you to separate it, right? It's mixed so perfectly together that you cannot separate the powder from the water once again. Heterogeneous mixtures are not this way, however, they can be separated. And I like to think of salads for this example. In a salad, you can physically see the onion, the tomatoes, the cucumbers there, right? You can separate them. So you have a heterogeneous mixture. And if you want to visualize it a little bit more, in the top right corner, you can see this picture right here. For heterogeneous mixture, the pink is visibly separated from the green. All of the greens are together. All of the pinks are together. You can easily break them apart. But in a homogeneous mixture, they're so perfectly mixed in together that it's really, really hard for you to split them up. So what are the ways that you can separate heterogeneous mixtures? You can separate them through filtration by using a filter to separate a liquid from a solid. You can separate through crystallization and distillation. These are two more complicated processes, but they end up separating liquid from solid. You can have your liquid evaporate from your mixture, leaving the solid behind. Or you can manually try to do it yourself by doing decantation, which is when you carefully try to remove the water from the solid, right? An example we like to use is separating sand and water. Now let's talk about chemical changes and physical changes. Chemical changes alter the composition of matter, right? They rearrange the bonds. So while your original atoms will remain, the molecules are going to rearrange. Let's say you have water and it goes through some random chemical change. At the end, your product is still going to have hydrogen and oxygen. The original atoms, they're going to be the same, but your molecule is not going to be H2O anymore. Instead, it's going to have a different arrangement that's going to make it a different compound, right? So chemical changes actually alter the composition of the matter. And examples of chemical changes include rusting and burning. Physical changes just alter the state or appearance of matter. They don't break the bonds, the chemical bonds between these atoms, right? So it's just changing the way that something looks. And examples include evaporation and melting because you're just changing the state of matter. Let's talk a little bit more about physical properties and chemical properties. Physical properties include odor, boiling point, melting point, taste, color, appearance, density, volatility. Physical properties, again, to put it into perspective, it's just changes in the way that something looks, right? Changes in smell, changes in taste, and color, changes in these more visible characteristics. boiling point, melting point, and volatility, which is the ability to turn into gas, are also physical properties because all you're doing is changing the state of matter. You're not changing the chemical bonds. In chemical properties, however, you are changing the arrangement of these atoms and molecules, right? So examples include flammability, corrosiveness, oxidation, acidity, toxicity, and reactivity. These words all sound like change to me, right? They sound like something's going to drastically change and no longer be the same. And I'm going to use a really simple example for you to understand this. Let's start with physical property. I have a piece of paper. I cut it in half. Is it physical or chemical? Well, it's a physical property because I'm only changing the appearance. Instead of it being a full paper, it's now going to be half a paper. What if I take a paper and burn it? If I burn it, that paper is no longer paper, right? It's changed completely. It's now ashes. You can't take ashes and make them back into paper. That's the difference between physical and chemical properties. And one of them, you still have paper left over, and the other, you have ashes. You can't revert the process and get paper again, right? It's a permanent change. So now let's do a concept check. Let's apply what you've learned. You can go ahead and pause this video and try to answer the questions, but I'm going to go ahead and move forward and review the answers. Number 1, sugar dissolves in hot water. The key word that we need to understand here is dissolves. Dissolves is just changing the state of sugar, right? You're taking sugar, which is a solid, and dissolving it in hot water to get a mixture of sugar and water, right? But sugar is now going to be a liquid instead of a solid. All you're doing is changing solid to liquid, and that is a physical change. You're just changing the state of matter. 2, sugar burns in a pot. Keyword burns. Anytime you see burns or flammable, that's going to be a chemical change. Because if you burn sugar, there's no way you can take that sugar and make it granulated sugar once again, right? Now it's going to be caramel. Number 3, a metal surface becomes dull after abrasion. Abrasion just means scraping, right? So you're scraping something. All you're doing is changing the way that it looks. It's like if you took your phone and your phone fell on the floor and the glass broke. It's still glass, it's still a screen, but now instead of looking nice, it's all scraped up, right? It's changing its appearance. It's changing physically. Number 4, a metal surface becomes dull on exposure to air. So here we're having a metal surface react to air. And if we remember, reactivity is considered a chemical property. So because this metal is reacting to air and becoming dull, we consider it a chemical change. Now let's try this example. Physical or chemical property. Again, go ahead and pause the video, but I'm going to go ahead and move forward. Let's take a look. Silver gray metal melts at 420 degrees Celsius. Keyword here, melts. When you melt something, all you're doing is just changing the way that it looks, right? It's the physical property of melting point. Number 2, metal dissolves in acid. Keyword, acid. I know that in the last example, we saw, sugar dissolving in water, and it was a physical change. But the key word to know here is acid. Anytime you see acid, you need to remember acidity. Property of acidity is a chemical property. Number 3, metal density. Density, again, it's a measure. It's something that you can see. It's physical. Density is a physical property. And number 4, metal reacts with oxygen. Keyword, reacts. You're having a reaction. This is reactivity, and it is a chemical property.